And so unlike arbitrage mint, the amount of Dexy that's minted is bounded by the amount that's in the liquidity pool, falling in the liquidity pool. So there's the bank reserves and Dexy's pool per table. And then in the maximum amount, your row is just represents the fraction of like percentage of the volume in the liquidity pool. So for the bank, when there's a defect, the bank can intervene into the liquidity pool in two ways. So the first is by injecting base coins. So if the oracle price is lower than the pool price by like a sort of significant amount, and the difference holds for a delay greater than T sub intervention. So again, this would be like a primary data set. Then the rule applies. In this case, the bank still has reserves or must have reserves because you're going to inject. The bank will inject its reserves into the liquidity pool. Yeah, and it does this until the pool price increases enough to that, so it's close enough to the oracle price. Yeah, so it's not just going to dump all of its reserves right away, or like or all of it until it reaches the oracle price. It's bounded by some fixed percentage of the total reserves. So ideally, you want it's like a small number, and that's because as we'll see later on, it's like this process can happen multiple times. So it's like cyclic, it's like periodic. So you don't want to dump a lot of other institutions and reserves right away. So as a consequence, the bank reserves decrease, and the LP price recovers. So here in the table, this happens when we're below the Freeman range. When R is below the lower bound of the Freeman range, and then it recovers. It'll inject to recover until 1 plus epsilon intervention, so this epsilon would be like the primary unit side, but it should be less than the upper bound of the Freeman range. And the alpha represents the percentage of the total reserves, like the max you would want to inject into the liquidity pool within one intervention. So the second way that the bank can intervene into the liquidity pool is by extracting or removing stablecoins. So the first way, one possible way to do it would be to burn the stablecoins in the liquidity pool. So here the oracle price lower than the pool price by a significant amount. And yeah, the president has to hold for an amount greater than Q burn, and then the rule applies. So again, this would be like a primary issues. And in this case, the bank has no reserves, so it's like a last resort. This is a solution, and it'll burn the stable coins until the LP is in the stop withdrawal state. So this is like the LP rule where people can't deposit their LP tokens and get their liquidity back. So in the table, we see that that percent, like you want the R to be less than the intervention R. So like you can think of the first line of defense as the intervention of the bank, and then if it keeps depegging, then the last resort is this burn. And you want the burn period to be much greater than the intervention period, because again, it's like a last resort thing. So you want to make sure that like maybe there was a natural stabilization for people just trading. So as a consequence, the banks remove Dexy from the liquidity pool and the LP price recovers. So similar to burn is extract for the future. So the parameters are basically the same as the burn case, but instead of burning the tokens, you store them you lock them up, and then inject them into the liquidity pool again at a later time. And in this case, we do it when the Oracle price is greater than the LP price, and it's prioritized over arbitrage minting. So arbitrage minting happened when the Oracle price is greater than the LP price by some amount, but instead of prioritize it. So basically, if there's locked Dexy, you want to inject that first before allowing arbitrage minting. So Dexy moves from the LP and the LP price recovers again. And here the recovery, so you go recovery is considered once you reach the stop with Wall Street state for the R value. So during intervention, the bank adds a portion of its reserves to the liquidity pool to control stability. But the question is okay, well, how much reserves do you need to do this? How much would you need? So for example, a sudden Oracle price crash could cause an intervention to make the liquidity pool price match the crashed Oracle price. Intervention then causes the LP price to match the Oracle price, and then so theoretically, the circulating supply of Dexy stablecoins that's not in the liquidity pool could be sold at this new lower price. So if you want to know the worst case scenario of base coins you would want in the bank, it would be the sum of these two values, E sub intervention. So the amount that's needed for the bank to intervene in the liquidity pool to lower the price, as well as the amount that corresponding to the circulating supply of stablecoins. So one possibility would be to only allow minting, once there's enough enough base coins in the bank, but this number would be very large in practice, and so it would be unmintable most of the time. So I'll go over how the bank interventions relate to stability. So as we saw, for the first sort of line of defense or stability mechanism is by injecting base coins to the bank. When you're in the Freeman range, it's self-stabilizing, kind of. You're just relying on people trading in the liquidity pool and by freely minting the token stablecoins for the bank to increase the supply. So and then intervention happens when below the Freeman range after a delay. So the reason for this is that you want to, so once you're below the Freeman range, during this delay delta, you would still want to rely on a self-stabilization of people just trading with the liquid people to see if maybe that could bring the peg back to the normal range. So intervention happens if it's really necessary. And the way it is self-stabilized is from the arbitrage opportunity. And as I mentioned, if the intervention fails, then you could have this scenario where you're oscillating between self-stabilization and then periodic intervention until the bank reserves are depleted. So that's what you want to make that alpha parameter like a small percentage, like 1%, for example, because if this oscillation happens in each period, it would be like 1% only of the remaining amount and then all the way until depletion. So this would take a long time. So the point is to like reaching the second stability mechanism, like make sure that it takes as long as possible. So if all that even fails, then you have this last resort, which is extracting funds from the LP. So minting also helps with the stability because you're not able to mint all the time, right? It's restricted. So during free mint, even during the free mint range, even though you're within the range, you're still limited by the volume of the liquidity pool. And in arbitrage minting, the maximum you can mint is determined the values in the liquidity pool once you reach this rule. So these restrictions means that the stablecoin gets issued much slower, and a benefit of that is that it prevents like large whales from accumulating large amounts, which could prevent like price swings in the pool. And then the constant product formula is larger bank runs, but even if the work bank runs, then the pool price decreases, then this could get fixed by the first stability mechanism. Yeah, so just quickly, like, this has been implemented in the UTXO model on Ergo. So what's cool is that in general, there's no like one monolithic contract that does everything. Like one giant one for the banker and one for the LP. The bank only tracks its own states, so like the tokens that is issued or the reserves that is accumulated. Each stability mechanism has its own contract, as well as the each minting option. So for example, here in this free mint diagram, you can see like there's the bank, each box there's like a contract. So the free mint action and all logic associated to that is in the contract. So it's like separation of concerns in software development. So even though it's more complicated because you have more contracts, but each one is simpler. And there's been a gold implement, one pegged to gold and one pegged to USD. So some further analysis would be cool. Would be to see, like, try to formalize the stability theorems, and then one way maybe would be like using the bank and LP rules and the proofs as arguments for, and then also in Jet and Gluon is interesting. Like there's defined notions of stability and like what stability means to be a stablecoin, and it would be cool to see how you could maybe adopt those in the case of Dexy. Yeah, that's it. Thank you.
Any questions? Can be some questions to that side, I guess. So any questions?
So I have a question.
Okay.
Yeah. Can you hear me, Luca?
Yes.
Okay. So I'm concerned about that burn operation, that the bank can do. So if I'm a user, if I'm a liquidity provider, that burn operation can mean that the bank can destroy the stable coins that I had included in that liquidity pool, right?
Yeah.
And
right. So in the like Dexy call.
Yeah. So that's not my question. So my question is, like, there might be other liquidity pools, right, between Dexy and Erg, but the bank monitors only one of them. So why would people provide liquidity in?
Oh, hello.
Hello. Are you back?
Yes.
Okay. So why would people provide liquidity in that particular liquidity pool where the bank can potentially burn their stable coins instead of providing liquidity in some secondary liquidity pool?
That makes sense. Yeah, that's why in the actual, for example, in the practical implementations for Dexy Gold and Dexy USD, or extract for the future is implemented instead. So the people's tokens aren't actually lost forever. It's just to show I just included both to show
Yeah, so the actual implementation has
The
extract
difference.
to the future instead of burn. So your stable coins are extracted for the future recovery.
Okay.
Yes.
So the burn operation is not implemented.
One year is just for illustration.
No.
Okay, okay.
Instead, extract to the future only.
Okay. So eventually, if things go well and things recover, those stable coins will be returned to the
so on
liquidity
recovery,
pool. Then.
stable coins are going to be unlocked. And going back to circulation. So
Okay.
you just need to wait till recovery.
Okay. Thanks.
Thank you. Any more questions?